NASEO. Thank you, Jasmine, and I'm joined by Jasmine Shah, my colleague at NASEO, is running things behind the curtain and making it happen, as well as by our NARUC colleague, Jeff Loiter, who I will offer a chance to greet you in a few moments. So welcome to today's webinar of the NASEO-NARUC Grid Interactive Efficient Buildings Working Group. And we are very happy today to host a presentation from Rajiv Shah of Octopus Energy Group, who will be speaking on scaling demand flexibility with software. Before going over some housekeeping and providing a little bit of an overview to the working group for those of you who are unfamiliar with us, I'll invite our NARUC friend and partner, Jeff Loiter, to say a few words. Jeff?
Thanks, Rodney. Very happy to be here. We at NARUC really value our partnership with NASEO on this, the state energy offices and state utility commissions. Increasingly, there's value in their collaborating and communicating and sharing thoughts about how the energy system is evolving. And so we're really grateful that DOE has provided funding that we can work together with them on this and some other efforts. We also do work on distributed energy resources and microgrids and distribution system planning with NASEO. And as I said, we really value those partnerships. So glad to be here today. And thanks to Rodney and Jasmine and NASEO for really leading the work on the GEB working group and pulling this together.
And there's mutual admiration. We greatly value our collaboration with NARUC, a lot of overlap, and very happy to work together as a community. So next slide, please. A little of housekeeping. Please mute when not speaking, and please use the chat box. I think there is not a Q&A box, so use the chat box to offer questions, and we'll see how it goes towards the end if there may be opportunity for verbal questions, but the chat box is there and available. We are recording this, and the slides and the recording will be posted. Next, please. So a little bit of an overview of our working group and our activities for those of you who may be unfamiliar. We are supported through the generosity of the Department of Energy's Building Technology Office to work on grid interactive efficient buildings, demand flexibility, grid edge, virtual power plants. There's almost a panoply of terminology over this realm. The interest is in how grid edge management can lower costs, enhance resilience, reduce emissions and other adverse environmental impacts, help control and mitigate peak loads, moderate ramp rates, and provide various grid services. We're interested in enhancing energy efficiency and the opportunities for grid edge management to integrate distributed and renewable and other energy resources. So some of the fundamental questions are, how can we optimize facility interactions with the grid? How can we coordinate distributed resources? How can state policies, programs, and regulations advance the benefits that these sorts of resources and demand flexibility can provide? And what are roles for states, facility owners and operators, utilities, technology and service providers, and others to make this happen? We offer forums and webinars. We offer opportunities for state exchange. We've been fortunate to be able to facilitate some technical assistance from the national laboratories. We offer our own reports and resources. Several of the covers are there on the screen, as well as pointing to others, resources, toolkits, reports, and so forth. Next slide, please. The working group includes about 30 states and territories through their state energy offices and utility commissions. We also are open to utility consumer advocates and have a couple of them in the working group as well. We are ably led by two co-chairs, Liz Reichart, now with the Massachusetts Department of Energy Resources. She was previously with the Washington State Department of Commerce, and Ashley Norman of the Hawaii PUC staff. Next, please. So just a little bit on some recent and new items. It's an eye chart. I will not read them all. We do encourage you to visit our website. We have a general page and then a resources page with an awful lot of stuff there. Just a few recent items. Department of Energy released its Pathways to Commercial Liftoff update to its virtual power plant report recently. I can commend to you also another DOE report, Sourcing Distributed Energy Resources for Distributed Grid Services. It's really quite good. There is a series of Lawrence Berkeley National Lab reports on virtual power plants and demand flexibility that have been released recently. We will also point you to the Colorado Microgrid roadmap, and I'll put in a plug for our sister state microgrid working group, another NASEO-NARUC collaboration, which will have a webinar in March. And recently, the Maine Governor's Energy Office had an effort that created a distribution system operator feasibility study, which is worth taking a look at. And another tidbit is the city of Ann Arbor, Michigan has established a sustainable energy utility, which will run local solar and battery resources in parallel with the incumbent utility. It seems to be kind of a unique design and something to keep an eye on. And just a little point to our last working group forum featuring the RMI virtual power plant flip book and cases from a couple of utilities. Next, please. So upcoming, and I think Jeff will say a little bit more about this through another collaboration among us. We have some support again from the Department of Energy to do integrated distribution system planning. There are a couple of in-person workshops that are coming up, and I won't say too much more about it since Jeff can speak to it.
Thanks,
And
Rod.
yeah, and we are looking for suggestions for future forums and webinars, and some of those are listed there, but we are always open to your suggestions. So I think with that, let me hand it to Jeff to offer a few words, a few additional words.
Thanks. I'll keep it brief here. First, very important. I know that this is a public webinar, and so you may be here from a place other than one of our member organizations and NASUCA. And these in-person trainings are only available to our state agency folks. That's part of the requirements that go along with getting the DOE funding, and that it's provided for the benefit of the state agency folks. This is a training that we do in multiple locations, multiple times a year to try to make it easy for people to get there. We did our first in December in Charlotte, and it was a big success. And we're taking all the good feedback we got from there to continue to improve it on the margins. But if you come to one of these trainings, you will get a number of expert presentations from staff at Berkeley Lab and some other entities on various topics within integrated distribution system planning. And in particular, this time around, we're focusing a little bit more on electrification and distributed energy resources. I will also add that in both of these two upcoming trainings, we have optional site visits to help entice you. In Detroit, on the day after the training on the 13th, we are working with Electrion and others in Michigan who are have a electric wireless charging road pilot, so that fleet vehicles that drive over certain segments of road can actually get their batteries charged as they drive along. So we'll see and learn more about that. And in Denver, we are working with the folks at the National Renewable Energy Laboratory to see their energy system integration facility, where they do a lot of great research on all kinds of equipment on the electric system and how it works together. Um, so please visit our website. I will put a link in the chat and uh, visit our website to learn more about this. And also, if you are not from one of our member agencies, you can find links to playlists and presentations from past versions of this training. So even though we can't welcome you in person, we certainly encourage you and welcome you to review the material on your own schedule. I think with that, we're ready to hand it over to Rajiv. Rajiv, it's nice to have you here. Nice to see you again, as always.
Yeah, thanks for having me. Let me get my slides up on the screen here. I think that probably worked. But
Yep.
yeah, really, thank you, Jeff and Rodney, uh, and thank you to the working group for inviting me to share some thoughts with you today. My name is Rajiv Shah. I am the head of North American Policy and Markets for the Octopus Energy Group. I'm going to be in that role for just another couple days before I make a move over to the Kraken side of our business, where I'll be similarly leading up regulatory work for our software arm, Kraken Technologies. Uh, so really, without further ado, let me just kind of get into this presentation. So just walk you through an agenda very quickly. I'm going to just very quickly provide an intro to the Octopus Energy Group and our software arm, Kraken. Kind of lead in with a little bit of an enunciation of a problem statement and some of the challenges we're facing as we try to scale the management capabilities, whether it be sort of VPP, direct load control, et cetera, of DERs. And then kind of walk you through some of our thoughts and considerations of what we need to keep in mind as we try to realize our ambitions for scaling demand side flexibility and VPP solutions. Focusing in on three areas: the promotion of market-based solutions in how we value DERs, the importance of interoperability, and just a quick intro to an effort that Kraken and Octopus have launched called the Mercury Consortium, and it's now being led by EPRI. And then just highlighting, our experience on how we've arrived at some of the sort of achievements that Octopus and Kraken have realized in this space by taking a very customer-centric approach to this. And so I want to kind of get through all of this pretty quickly so we have plenty of time for any Q&A or discussion afterwards. So first, quick intro to Octopus Energy Group. We're working across four key verticals in the energy transition. And I should just pause for a second and note that the company Octopus Energy Group was founded by some really tech-centric founders who, their experience was not necessarily in the energy sector per se. They had a lot of experience in enterprise technology systems, and through that experience became more and more exposed to the deployment of these enterprise solutions, particularly those that relate to the management of customers and energy assets uh, through that work. And their observation back in 2015, when this company was founded, is that some of the digital tools, some of the enterprise IT infrastructure is ill suited for where utilities and energy companies are today, let alone where they're going with the decentralization of infrastructure and the growing generation capabilities that are being served by renewable intermittent resources. And so their thesis here was sort of, let's create a tech platform purpose built for energy companies with the energy transition in mind. And of course, when you do that, no one is going to raise their hand and be the guinea pig to sort of re-platform some of their backbone IT on an untested system. So we became an energy company and started serving customers in the UK, really to validate our tech. And since then, that business, Octopus Energy, has grown across three verticals. We now have 8 million customers in 8 countries around the world, are the largest electricity and gas supplier in the UK, and have a retail business in Texas that we're trying to grow here in the US. We have a generation fund management arm that's managing over $7 billion in mostly wind and solar assets around the world. We have a services arm that is doing everything from leasing EVs to manufacturing heat pumps to installing DERs in people's homes. And we've also established a charging network of charging networks that has several 100,000 charge points accessible through a single app interface across Europe. And then lastly, kind of the meat and potatoes of what my focus is going to be today is our tech arm, Kraken. It's a single end-to-end platform for managing customers, billing, and assets. It's been deployed to utilities and energy companies in 18 countries with 50 million contracted accounts and 43 gigawatts of flexible assets under management. So just a quick overview of what Kraken is. Kraken is this sort of what we call an end-to-end operating system for future-focused utilities. We have a customer module that's doing everything from CIS and billing, meter data management, to sort of your customer engagement capabilities. We're managing the deployment of field workforce. We have flexibility capabilities both on the grid scale side and the ability to control and optimize, grid scale batteries, even some peaker plants, and a smart flex capability that's really about some of the consumer level DERs that are going to be really the emphasis of the discussion today. And lastly, Kraken Grid, which is providing distribution level insights, low voltage monitoring, and congestion forecasting. But the real focus today for me is going to be on the customer and the smart flex side of this platform. And so, really focusing on the left side of this screen, smart flex, we're sort of DER agnostic in the types of assets that we're managing. We're controlling EV charging. We're optimizing heat pumps and smart thermostats, as well as home batteries and rooftop solar. 42 gigawatts contracted capacity, of which 1.41 gigawatts breaks down into that sort of smart flex consumer level piece, including what is Europe's largest EV aggregation, or VPP, in the UK, where we have over 200,000 EVs that we're scheduling charging on every day. So kind of leading into the meat and potatoes of what I want to kind of be focused on today, we're going to see this bow wave of DERs coming onto the system, and it's already sort of changing dynamics of the grid, power flows, increasing demand, changing load shapes, and that's leading to these system balancing challenges and cost concerns for end use customers. And so, really to manage those challenges, we're seeing utilities deploy various demand flex tools, whether you call it a distributed energy resource management system or a VPP. But in our view, the results have been sort of smaller than what we would hope and quite siloed from a programmatic perspective. And so kind of walking you through some of the challenges as we see them. The first challenge is this proliferation of DERs that we're expecting on the system. And so BMEF has sort of projected where we're going to be in 2030. And across a number of different countries, the US, the UK, France, Germany, Italy, Spain, Australia, and China. And we're going to see 200 million new devices by 2030. That's from 40 million devices today. And so, alongside that that kind of leads into the second challenge here, which is a changing consumer demand profile. For decades, this has been sort of the consumer, the residential household customers load shape. And you know, this is nothing new for, I think, most of the folks on the call. But now with the introduction of rooftop solar and the reductions in sort of the middle of the day energy consumption from the grid that we've seen, now you see the so-called duck curve. You add these two camel humps here from the electrification of heat, and now you're seeing this more pronounced morning peak, particularly in the winter, and a magnification of the evening peak. You layer in EV charging and people plugging in when they get home, and now your impacts to that evening peak become even more pronounced. And so this is what the new energy use and the new load shape is going to look like with the proliferation of DERs. And the question becomes how to manage it. How do we get something? And I'll admit, I kind of drew this green dotted line here, but how do we arrive at some sort of new flexed energy use profile where perhaps we're shifting that EV charging to overnight and lifting up the dip that you typically would see in the late evening, early morning hours, preheating or pre-cooling a home in the morning to address that more pronounced morning peak, storing some of that solar energy and consuming more during the day, and then again pre-cooling or preheating as we move into the evening peak, and shifting some of that EV use over. This is sort of an idealized load shape that I think we should all be striving for. Last challenge is sort of the growth in demand that we're expecting and the associated costs. And so, you know, the liftoff report, actually the 2025 update that was referenced earlier, has identified, you know, to address the growth in demand and the expected retirements, the potential for DERs enrolled in VPPs to be providing 80 to 160 gigawatts of the expected sort of 2030 peak demand needs at a bulk system level. And in order to get there, I think we have to sort of do better than we're doing right now. And so where we're coming from as an organization is that we have over 50% of eligible EVs enrolled in our VPP. Whereas I think, you know, kind of looking across the country, by and large, you have 20% or less of eligible DERs enrolled in VPPs or demand response programs today through existing utility or third-party platforms. That 20% figure, you see that number sort of more with smart thermostat type programs, and it's actually much lower when you're talking about something like EV charging or home battery management. And so the point here is that if we continue to go at sort of a low 20% enrollment number, you're not going to get to 160 gigawatts. That 20% enrollment only really gets you to about 80 gigawatts of that aspirational sort of number that has been laid out in the liftoff report. We really need a new strategy to sort of hit scale here. And so I just want to kind of zoom in on one of the programs, SmartFlex, that Kraken offers our clients. And Octopus Energy has branded this as Intelligent Octopus for what it's doing with EVs, with heat pumps, with thermostats. And what we're trying to do for customers is really give them a seamless experience from sort of enrolling the device through sort of what they are dealing with on a day-to-day basis. And so these screenshots show the first three, that enrollment journey. We're trying to make it as easy as possible for a customer to get their device into our system, and then once they're there, making it really easy for them to express their preferences, whether it be sort of their temperature preferences or their charging preferences. And then we're mapping out against those preferences a individualized charging schedule for the device in order to provide the most value that we can return to the customer as well as to the grid. This is just some screenshots of what that looks like for a smart thermostat customer in Texas. Again, one thing I'll point out is that we're letting them know if we're modulating their thermostat, controlling it by including sort of that smart event feature there. And so on the warmest Texas days, we've been able to leverage Kraken to provide a 40% reduction in our customers' peak load when the grid is stressed for these enrolled thermostat customers. That load reduction increases as peak load increases, and on a per customer basis, that amounts to about 2.5 kilowatts of peak load flexibility on average. And what's really interesting about the way we're doing this is that it's not a one-size-fits-all approach for our customers. We are using data to constantly experiment and innovate and really kind of right-size what we're doing to how the customer has been behaving. So one thing that we've done here is we've actually cohorted our customers from sort of really sensitive customers to sort of changes in their home, the temperature that they're experiencing in their home, to those customers that are not so sensitive. And that's allowed us to really have a much better predictive sense of what we can squeeze out of each household and actually tailor how we're running these events to the customer's sort of behavioral profile. We've actually iterated on this further in that we know when the HVAC system is re-engaging for our customers after we've set a thermostat hold, perhaps increasing their temperature by about 3 degrees, which is what we've seen for most customers is what they're comfortable with in terms of a fluctuation from their thermostat setting. And so that actually has given us a proxy for really assessing what the thermal envelope is for our customer and associating sort of the durational capability with that thermal envelope. So how do we kind of get to scale here? And the first thing I want to kind of walk you through is just sort of what needs to be done to better sort of value the benefits of DERs and VPPs. And so, I mean, this is probably a pretty simple diagram for most of the folks in this room, but we're really talking about energy benefits and non-energy benefits, and focusing in on the energy benefits side of the equation. It's everything from sort of your bulk energy services to the distribution and grid edge. In the UK, this is actually the different market price signals that we're optimizing our VPPs against. Everything from day ahead trading and sort of the real-time energy markets to contracting with distribution network operators to address some of their congestion constraints. The only thing to highlight on this pretty wordy slide here is that there's different ways that you can do this depending on how your utilities are organized. If you're not in an RTO or ISO bulk system market, you're going to be relying on avoided cost or least cost analyses across the spectrum. Really, when we're talking about energy benefits, and whereas where you have that RTO ISO overlay, you're certainly going to have market values to rely upon uh, from your grid operator. And so, from our perspective, there really needs to be sort of an evolution in how we're using data, kind of getting into sort of utilizing some of the more granular data that's available to us through smart meters and from the devices themselves, as well as the processes that stem from from that data. So the really big things I'd highlight here for this group is how do we advance some of the forecasting models? How does this sort of translate into some of the price signals that that we can put out into the wild and start getting some of the entities that are managing load or the end use consumers to sort of act on it. I think taking this to the SEO and PUC perspective for this audience, there's a lot that can be done to sort of move the needle on this valuation question. There's a lot of great work being done in places like California on development of fair compensation mechanisms. California's DSGS, feeder in New York, what's going to kind of come forward from the Powering Up Colorado legislation. And the goal here is really to align DER evaluation with whatever your goals are around resilience, equity, decarbonization, reliability, et cetera. And so I see a real role for you all to be supporting the development of tools to kind of determine where these DERs are going, to support assessments around locational value. And I think a fundamental point here is that we see it as an imperative. We're seeing so much happening on sort of the bulk system side of this equation. And to take some of those learnings and some of those approaches and start to develop better ways of valuing sort of what's happening on the distribution side. There are some programs that utilities are administering, et cetera, but how do we really create price signals for flexibility from the distribution side that can be sort of added value to align the benefits of DERs with what they're actually doing for folks. Second piece here is the importance of interoperability. We as an organization are actually, if I was completely speaking self-interested, we're ahead of a lot of others in terms of the integrations that we have with various OEMs and devices. But this universe is crowded, and it's only becoming more crowded by the day. And the level of effort to kind of create our own bespoke communication protocol with each one of these OEMs and each disparate device takes a lot of work on our side, and the results are sort of uneven. We could have the ability to directly control individual DERs offered to us from one manufacturer. Other manufacturers might only allow us to control sort of cohorts of DERs, maybe groupings of 10. There's variance in terms of how quickly we can send commands to DERs and how quickly they can respond. And given all of this and the fact that there's also unevenness in how much it costs for us to do this, API fees that manufacturers put forward to us vary quite a bit. It creates an issue of complexity that really challenges our ability to scale our offerings. And so what I would say here is that we need standardized signals and communications across all DERs for utilities, aggregators, and ISOs to be able to dispatch them to their maximum benefit. And so we really should be requiring interoperability standards for DERs to receive, in the first instance, some of the deployment dollars that we're putting forward to them. It actually is best contextualized by this illustrative scenario, which Octopus Energy has actually experienced here in Texas. So consider a customer who owns an EV from Tesla, a battery, or sorry, an EV, a Chevy Bolt, a Tesla Powerwall, and a Google Nest thermostat. Well, in Texas today, that Chevy Bolt can only be sort of managed by a handful of retail electric providers and sort of brought into the VPP pilot that ERCOT and the PUCTs have stood up here. That Tesla Powerwall can only actually be managed by one retail provider in Tesla Electric. And that smart thermostat can only be managed by NRG due to an exclusivity arrangement they have with Nest. And so the end result there is that customer has to pick and choose which DER or rep they want to sort of use for that device, and they're leaving value for themselves on the table from sort of the flexibility characteristics of these devices, and the grid is also not realizing the full potential and value of these resources. And so that issue is why we launched Project Mercury with EPRI late last year. And so Project Mercury, it's a consortium. We sort of spearheaded the ideation of it, but it's being led by EPRI to bring together OEMs, utilities, regulators, and tech providers. And what we're seeking to do is really develop sort of functional guidelines for consumer devices that are going to allow that sort of seamless interoperability, and at the end of the day, allow them to provide real grid services and value. So what we're seeking to do here again is at the forefront is get some of the manufacturers, the OEMs, in the same room as some of the energy companies and tech providers to enunciate, like, what do we need? What do we need? What level of control do we need over these devices? How quickly do we need them to be able to respond? What are sort of the baseline functionality and controllability that we need to support the grid services that we care about? And from that, we want to kind of develop a certification. What we're not going to do is develop new standards. There are a lot of great standards that are being developed or ideated on, and we don't want to kind of add more noise to that space. What we might say, though, is that this looks like a good standard. These are some of the guidelines that should be followed in how the standard is implemented, and that might build into a certification process. The end goal here, and some of the idea came from the way the computer hardware industry and device hardware industry got together and created a Bluetooth standard, is for that Mercury symbol up top to kind of become an expectation around how DERs are able to communicate. This is just an idea of some of the founding members, and I would just note that Mercury is very open to membership of regulators and government bodies. So we'd welcome any interest in joining this consortium and working with us towards sort of realizing the vision here. Lastly, I just want to highlight the importance of customer centrism. First and foremost, I mean, Kraken, in its initial sort of development, was a customer-focused system. And why do these back-end customer billing systems and customer relationship management systems matter when we're talking about sort of grid edge flexibility? And in part, this is speaking to the to the challenge that I was describing earlier around sort of low enrollment. You could have the most sophisticated control room capabilities and algorithms for optimizing your VPP. But if you don't have a way of sort of bringing a compelling offer to your end use customer and engaging them and sort of enrolling them into the program, I think that's going to challenge your ability to actually sort of realize the scale of DER management or VPP that you might otherwise want to see. And so, there's a lot of great documented lessons that VPP providers like us have offered regarding customer engagement. And I just really want to focus in on the incentive design piece here for the folks in the room. And this is really, I don't think it's about maximizing financial incentives so much as aligning financial incentives with the actual benefits that DERs can provide. And so, where we've sort of started with this is let's get some simple programs out there. And those incentives have largely been siloed, focused at different customer segments or asset types. You might have one program for EVs, another management program that's looking at home batteries, another management program for smart thermostats. But where I think we need to be going is actually creating sort of device agnostic price signals or incentives that allow for sort of dynamic retail pricing. And there's pros and cons to the more simplistic approach that we have today and sort of the evolution. But if you just kind of look at the first and last rows of this table, where we are today in many respects is sort of these one-off incentive designs, right? You may get a $20 gift card or a $20 credit applied annually for enrolling your thermostat or EV into this program. And that doesn't necessarily translate into a clear expectation on the consumer on what they should be doing or what their device is going to be doing. And you get to the sort of holy grail in our minds of sort of a device agnostic retail rate with time and location varying components. And that does actually create a much richer sort of signal for customers to respond to. And while it might be more complicated in terms of how you're going to explain these things to your customer, I would submit that we have ways to kind of actually make that experience for customers more seamless. Again, two of the primary drivers for this at the residential level are going to be EV charging and your HVAC system. And if you compare device agnostic retail rates with sort of direct load management capabilities that are emerging, now you have a way for customers to understand what's happening and have real skin in the game and monetary value that they're realizing in terms of bill credits or a reduction in their energy bills, paired with a seamless way to actually manage the assets. And so, not a lot to say here, but sort of, right, you got to walk before you run. And so I think a lot of the efforts we've started walking, but if we want to drive more customer enrollment, we got to be focused on engagement and providing that seamless experience and actually returning the true value of these assets to customers in a meaningful way. Last thing I want to note here is that a lot of the discussions that I'm hearing around the country are focused on, so what is the right construct for VPPs? Is it something like who's on first for delivering these capabilities? And we have, I almost think we're putting the cart before the horse in trying to answer that question, in that we haven't, before you answer that question, you actually need to be thinking about like, what are we trying to do here? And how are we going to be sort of evolving our price signaling, our ability to sort of deliver value to customers that own DERs before we even address whether it should be the utility, a third-party aggregator that is running this sort of thing. So I almost think this conversation should be paused, and we should be looking at sort of the middle of this diagram, and at this stage taking a bit of an all of the above approach. So with that, that is my quick and dirty presentation. My colleague Emma was supposed to be here to sort of supplement some of my insights here. Unfortunately, she got pulled into a personal conflict. But you can email either of us if you have any questions. And with that, I'll kind of turn it back over to Rodney on the Q&A discussion portion.
Thank you so much, Rajiv. A lot of good stuff. It's like from a fire hose in my perspective. There's a lot going on. Your company has had a lot of success abroad and in parts of the United States as well. Looking at the Octopus side, Kraken offers a lot of opportunities, not only for your firm, but for utilities and others that may want to do this. I do want to invite folks to enter questions into the chat. We already have a couple regarding communications and standardization. I would actually invite Commissioner Tom Plant of Colorado if he wants to verbalize his question. And I know Kadir Badir of California Energy Commission, I think, has a related one. So Commissioner Plant, please go ahead.
Yeah, thanks a lot. I appreciate the presentation. I was just curious about, I mean, you communicate with your connected devices through your software, but I'm wondering if there's a standardized communications platform that's used for any DERs, whether they're in the Octopus system or some other aggregator. And then if there's any kind of standardized mechanism for communicating then with the utilities for, event signals and dispatch capacity targets and all that sort of thing. What's sort of the state of the market at this point?
So I'll take the backside of your question first, in that because we are a software platform that could be deployed by the utility, the comms, say with their dispatch room, or sort of built in as we deploy Kraken into the utility. So we're establishing usually API channels into some of their other systems that they're using for the dispatch of assets or to communicate price signaling information, and that's kind of flowing into the Kraken system. And then standardized comms pathways with the DERs themselves, that is where it is sort of the wild, wild west right now, right? Some OEMs are compliant with or sort of have built their comms to the communication standards that have been established. Things like OCPP or IEEE 1547. Others are not. Many are not. And so the process of integrating with devices, and we've done a really good job of this. We have something like 90% of the EVs on the road today we have some level of integration with. It's a bespoke process where we have to actually build APIs or communication capabilities to the OEM API system and negotiate a commercial structure for that access. And so that's where we really do think there's room for standardization. That there's an imperative for standardization here, such that the comms and the functionalities enabled by those comms can be sort of maximized.
Kadir, is that responsive to your question as well?
I think that covers a part of my question, but when I heard Rajiv's presentation, I think there was also kind of a suggestion to look for a solution that can work across devices. So I found that interesting because, Rajiv, like you gave the example of CPP for EV charging stations. So if you get a new standard that works with all the devices, then it's going to be a new standard, right? We need to kind of go away from CPP.
Exactly, and that's part of the reason why we're not necessarily in the business of we're not trying to develop a new standard through Project Mercury. We're trying to sort of either we want to enunciate how the existing standards, which there are a lot of really great ones, should be implemented, and translate that into some sort of certification for DERs that creates sort of the dynamic that we see with Bluetooth today. 10 million devices are sold every day that are Bluetooth enabled. And it means the same thing whether you're buying a MacBook or an iPhone or an Android device. That Bluetooth capability, we all know how to use it, and we all know the functionality that it's going to provide. That's sort of the end goal of where we're going with this. Now, I don't know that you can have one single standard, as I understand it, for something like, let's say, controlling an EV versus controlling a smart thermostat, because the functionality that you are seeking through that, managing charging versus sort of controlling an HVAC system, is going to be very different. So I do think that you're still going to have different standards for different asset types, but within each category, we should be able to arrive at sort of what the appropriate standards are that folks should be required. And that's where I think commissions and state energy offices can actually be saying, like, no, we're not going to fund the purchase and installation of a device that we're not confident is going to be able to deliver that sort of operational functionality and controllability that we need on the back end. Let's make sure that these devices are sort of future-proofed against our desire to manage them over the long run. I hope that's helpful.
Yeah. Thanks.
Great. So a few other questions. There is some additional in the chat, but I did want to ask sort of a more general question of, are there policy, regulatory, or market features that appear either more or less conducive to effective demand flexibility VPP implementation? I mean, our members, some are in places with vertically integrated utilities, traditionally regulated. Others are in restructured states under ISOs and RTOs and FERC 2222. Your retail business is doing quite nicely in Texas, but things look different in different places. Maybe some comment on that.
Yeah, there isn't a one size fits all approach here. I think that is certainly like part of the reason why this company isn't just an energy business that is seeking to sort of monopolize our tech capabilities. We're seeking to kind of spread them, to a diverse group of energy actors, if you will, that span from that sort of vertically integrated construct to energy suppliers and aggregators in this space through Kraken. I mean, we realize that, like, this is a fantastic tool, and we kind of want to move that, to as many diverse business models as possible. But I also think, the one thing that is true across the spectrum, because again, if you're in a vertically integrated context, at the bulk system level, a lot of the sort of avoided cost or least cost approaches have evolved, or at least are in motion to evolve to some of the granularity needed to appropriately value the capabilities of DERs and the potential of VPPs. What is true across all of these different contexts, though, is that at the distribution side in the US, we do not have that same level of sort of innovation happening towards the distribution price signal. There are some efforts. I'm very curious to see how the Midas effort in California, for example, turns out. I think VEDR in New York was a great attempt, at least for your generation assets, to have the distribution value incorporated into one sort of price signal. But if I were to leave you with one thing today, it is how do we kind of, whatever your approach is going to be, a true market signal or a proxy by doing these cost analyses. How do we up our game, level up on the distribution and grid services side of the equation?
That's great. I see another question from OP Ravi. Does this person want to enunciate their question or just read it off the chat? Okay. So the question there in the chat is, it seems there's significant visibility in the wholesale market, but unfortunately, retail demand distribution side remains a black box even years after FERC 2222. Do you have any suggestions based on your experience to get better visibility at utilities/retail markets to offer DER flexibilities? And that, yeah.
Yeah, that's a great question. I mean, and it kind of dovetails on what I was just saying, and actually, this would have been one I would have punted to my colleague, who has who is just, I think, a bit sharper than this than I am on this. But earlier today we were talking, and she described to me, look, we have so much great granular data. The distribution monitoring capabilities of utilities are evolving, and owing in no small measure to some of the funding that has gone out or is going out of the door through programs like GRIP that are focused on creating a much smarter distribution grid. But from a system planning perspective, in too many places, we are sort of taking a one-size-fits-all approach to what we know about the grid. So a great example is sort of, let's just, I'm just hypothetically, the state of Massachusetts has an idea of like what the solar adoption average is across the state, but it also has granular information that you could actually say substation by substation, you know, what is happening, what is the uptake of solar and battery systems. And so from a system planning perspective, if we're just applying that statewide average to South Boston and planning for distribution enhancements at that level, we need to take this granular information and actually use it. It's a fundamental point there. So I actually think we have some of the infrastructure and the tools to do this. It's just been slower going to actually incorporate it into the processes. And that was part of the reason why on one of the earlier slides I highlighted all of this fantastic data, but it's how does that data get into, you know, translate into load forecasting or some of the other processes that we need to sharpen our pencils on.
Okay. I'm going to invite David Nemsow to, I believe he has a question at hand. David?
Thanks, Rod. And thanks a lot, Rajiv. Also, thanks, Jeff, for organizing this with Rod. This is really helpful. I want to understand better, Rajiv, what you were talking about before in terms of, everybody has multiple devices, some of which EV or HVAC can be quite significant, or batteries, and they have different software or apps from the OEM. So I get that it's a problem, but I wasn't quite clear if you were suggesting that the solution is people really need one piece of one ring to rule them all in terms of a software solution, or do they just need the different apps and software to talk to each other, or how we think about
Yeah, yeah. I'm sorry if I muddied that in how I
it?
was describing it. In short, I think you need, at least within each category of asset, um, sta a standardized communication protocol that all these assets are following, and open access um, for control of these assets, provided the customer is giving the entity the right to control it, right? And so I I spent 2 years. I spent most of my career before joining Octopus in state government, but I had a 2 year stint as general counsel for an EV charging startup. And in the EV charging space, you had a lot of these early companies with, just sort of their bespoke proprietary communications protocol for a lot of the early chargers that went out into the universe. A lot of these were being funded by state energy offices or ratepayer dollars. And then when these companies, a number of them uh, failed, right? And now you have the owners being left with assets that they actually can't have no way of controlling or updating or granting software access to someone else that might be managing, that they want to grant management capabilities to for the EV charger. You have this real stranded asset risk when you're basically have a more walled garden approach to communications. And so what started happening actually? Well, in funding applications or funding programs for EV chargers, we started to mandate that they would be um, uh, compliant with the prevailing charging standard, which I believe was OCPP. And by and large, you're not seeing funding go out the door for EV chargers unless they are sort of OCPP compliant. It was both at that time to avoid sort of the stranded asset risk. I think now there's an even bigger imperative to ensure that these can be managed by a utility or a third party aggregator, whoever the customer wants to delineate control of that device to.
Great. Well, we are over time a little bit, but let me ask one other question, and that is with regard to Project Mercury, what's the best way for states, the energy offices and the PUCs to either become directly involved in that, if that is possible, or to be kept apprised of progress?
Yeah, let me share with you after this event just a quick link. We have there's like a interest enrollment form that any organization around the world can join. So just express your interest, and we actually really want to grow the government and regulatory side of this quite a bit. So I think you're becoming a member should not be an issue for any of you if you're so inclined. I'll note that Bluetooth started from, with 5 organizations spearheading it. I think it was, I'm not going to name them all, but it was like NVIDIA, IBM, a few others, and it grew to tens of thousands of member companies today, and sort of that's sort of the collaborative universe that we're striving for with the Mercury initiative around this important issue.
Great. Well, we are over time. Thank you for a fantastic session. This has been very informative, very thought-provoking as well, and it's a very dynamic area. Thank you so much. We hope to keep in touch with you as progress is made in this area. And thank you to all our participants out there in the ether. And we will be, as you notice in the chat, we will be posting the slides and the recording. And we will let the working group, we keep them apprised periodically with updates. If you are an energy office person or a PUC person or a consumer official consumer advocate and you are not on our working group list and are interested, please let us know and we will welcome you. Thank you again, Rajiv. Thank you all. Thank you to my colleagues Jasmine and our partner Jeff at NARUC as well. Take care, everybody.
Thanks for having me. Bye.
Bye.